start. We have main engine start. 4, 3, 2, 1, 0, and liftoff. The liftoff of the space.
In our natural pursuit of knowledge, space has always mystified and beguiled us. Over the past 5 decades, we've pushed the final frontier inevitably onward into the ether. The cost has been colossal. Now every day, new data, new conclusions, and the thirst for deeper exploration propel us inexorably onward. The advantages of the discoveries made through space travel are myriad, but the fundamental curiosity as to what is out there will always fascinate and taunt us. Come with us now into the unknown and discover the disappearing frontier. Coming up in this edition of Disappearing Frontier, we continue to reflect upon the early 70s, a remarkable period in human history that heralded enormous strides in the field of manned spaceflight, space science, aeronautics, and computer technology. Then we take a quantum leap into the early 80s to compare and contrast the remarkable developments in many of the same fields of endeavour, and especially the advent of the most complex machine in human history, the Space Shuttle. Artists' impressions of the reusable shuttle, a craft that was still several years away from escaping the realms of science fiction and blasting its way into space time and time again. By 1973, many projects were well underway in preparation for a launch in the early 1980s. High-speed wind tunnels were used to solve the problems associated with re-entry, while the craft's recoverable booster rockets underwent many tests of their own. Other engineers prepared to undertake shuttle vibration studies to find out where the stress areas would develop. At NASA's Flight Research Center in California, the new X-24B lifting body was airdropped several times. The X-24 was developing maneuvering and landing capabilities for a future aerospace vehicle like the Space Shuttle. The scientific spacecraft Pioneer 10 was also making headlines in 1973 as it spent 210 days passing through the thousands of rocks, sand and dust particles that make up the asteroid belt on its way to this planet, Jupiter. On December the 3rd, after travelling 500 million miles from Earth, Pioneer 10 returned close-up pictures and scientific data as it passed within 81,000 miles of the giant planet. Mercury, smallest planet in the solar system and closest planet to the Sun, so close that it's difficult to observe from Earth, which is why the Mariner spacecraft was on its way for a better look. After swinging around Venus and picking up extra speed from its gravity, it was propelled on towards Mercury, reaching the tiny planet in March 1974. The craft's television cameras returned pictures, while other onboard instruments probed the atmosphere in order to better understand the planet and its makeup. Back on Earth, technicians worked around the Radio Astronomy Explorer satellite at the Kennedy Space Center. Its job was to explore the sources of low-frequency radio noise in our galaxy and beyond. Launched into orbit around the Moon, Explorer provided astronomers with a far better picture of extraterrestrial radio signals. Work also continued on the preparation for Viking, which was scheduled to land on Mars in 1976. Trying to answer as many questions as possible before landing on the red planet, scientists attempted to simulate the Martian atmosphere. Progress was also being made in preparing biological sensing devices in the hopes of determining if life exists there. NASA's sounding rocket project was still underway. The rockets probed the region of the Earth's atmosphere just below satellite level, just above the area where balloons return data. As many as 80 launches took place in 1973, with several in support of the named orbiting Skylab space station. Comet Kahutek was heading our way and was visible between mid-November and late January. Eventually it became brighter than Halley's Comet, which then hadn't been seen since 1910. 4 NASA spacecraft, sounding rockets, balloons, Skylab, ground-based observatories and telescope-carrying aircraft like this teamed up to form the most comprehensive comet watch ever seen. Astronomers were eager to determine the elements that made up Kahutek, elements that were expected to tell us more about the nature and origin of the Sun and other planets. Santa Barbara, California, Louisiana and Mississippi, Cleveland, Ohio, all these places, like many others, have one thing in common. Each was photographed by the Earth Resources Technology satellite that orbited 570 miles overhead. Since being launched in mid-1972, the Earth Resources spacecraft returned almost 100,000 pictures of our planet. It proved itself extremely useful in such applications as land use and timber inventory, crop identification, water pollution, and improved mapping. Investigators look forward to even more exciting possibilities for operational use in the future. For example, during the past summer, a remote sensing station was tested that could tell when optimal conditions existed for a forest fire to occur. In less than an hour, valuable fire index data was relayed via the Earth Resources satellite to the California Division of Forestry headquarters in Sacramento. The highly successful experiment had important implications for those areas most at risk at forest fires. Helping to verify images received from spacecraft was the U-2 High-Altitude Earth Survey plane. Flying at altitudes of 65,000 feet, the U-2 quickly evolved into a sophisticated research tool in its own right. These are just a few of the high-quality pictures returned. Pictures that have spotted smoke from forest fires in California and helped survey the extent of damage done by tree-killing moths in Washington and Oregon. The Lewis Research Center in Cleveland was the scene of a program to explore and demonstrate how navigation of the Great Lakes could be extended all year round. Ice maps were made with the help of a reconnaissance plane on loan from the US Army. Its special radar provided detailed images, similar to black and white photographs, while another plane recorded ice surface temperatures. NASA scientists also flew regularly in Coast Guard helicopters equipped with radar that measured ice thickness. To verify the instrument measurements against actual conditions on the ice surface, samples were taken along the flight path. With the system in place by the winter of '73, the shipping season was extended from then on, saving millions of dollars. Emphasis was placed on the development of executive aircraft as well as the problem of weight turbulence, tornado-like patterns of air that trail behind large jets. These vortices, as they're called, pose a problem for smaller, lighter aircraft following in their wake. Through laboratory and wind tunnel tests and actual in-flight analysis, NASA was studying ways to break up the whirling air masses, eliminating the danger to smaller planes. The US Army's Flying Crane helicopter was a unique machine. When the helicopter developed excessive vibrations under certain payload conditions, the Army was assisted by NASA in solving the problem. The solution developed involved bonding stiff, lightweight boron epoxy materials to the aluminium frame. The process eliminated the problem and provided an added weight saving of 60 pounds. The composite materials project had been so successful that test applications were soon planned for the wings, rudder and other components of large transport aircraft. At the Flight Research Center, test pilots were flying a plane without having to leave the ground. It was a new way of flight testing advanced aircraft that was both more economical and less hazardous. A typical flight involved air launching a large-scale model at high altitude. A research pilot in a realistically recreated cockpit on the ground, complete with flight controls, would fly the craft using computers and television. The television camera was installed in the model where the pilot would normally have a seat. This view was then transmitted to the test pilot. Since the research pilot on the ground had direct control over the model, he was able to perform high-risk flight maneuvers such as stalls and rolls. At the end of a typical 9-minute test flight, the model was lowered by parachute. In the final stages of descent, It was recovered in mid-air by a helicopter and brought gently to the ground for reuse. Then as now, speed and fuel consumption are factors that have great impact on the design and performance of future aircraft. This Air Force plane, the YF-12, was test flown to study such things. Other areas of research included heating, flight stability and control, structural dynamics, gust response, and since the plane would often cruise at 3 times the speed of sound at 75,000 feet, the physics of the Earth's upper atmosphere. Manned spaceflight, space science and application, aeronautics and research and development. 1973, a year of significant accomplishments. We move 10 years ahead now to 1983. NASA was set to launch a new satellite that would be able to observe the heavenly bodies in infrared. IRAS, as it was called, was an international project that included NASA, the Netherlands and the UK. The heart of the new Earth orbiting satellite was a highly sophisticated infrared telescope, supercooled to 455 degrees below zero, which gave it unprecedented sensitivity to celestial infrared radiation. IRAS was soon launched into orbit above the Earth's atmosphere by a Delta rocket. Over the course of its 7-month mission, IRAS scanned the skies with 4 different infrared wavelengths, detecting almost 1 million celestial phenomena that are invisible to our eyes but glow in the infrared. One such phenomenon is the birth of and death of stars formed from dust clouds. And as low-temperature dust gives off infrared, these unusual stars became easier to detect and track than ever before. The process also worked on stars that had already collapsed and cooled millions of years ago. The Infrared Astronomical Satellite looked at the stars in another light and helped astronomers to better understand the evolution of the universe. The early 80s also saw an unusual amount of volcanic activity on Earth, beginning with Mount St. Helens in 1980. At least 5 of these eruptions had poured more than 1 million tons of volcanic debris into the upper atmosphere, keeping NASA's scientists busy trying to determine the potential effects of these volcanic clouds on our environment. One thing the scientists noticed was that bad weather occurred for about a year following each large eruption, and they wanted to know why this phenomenon was taking place. Their primary concern was whether they'd inadvertently bring about bad weather conditions themselves by putting man-made objects into the upper atmosphere. Objects such as rockets or high-altitude aircraft that may affect the climate by releasing extra particles in the same way volcanoes have. A NASA U-2, one of the few aircraft in the world capable of flying into these volcanic clouds some 10+ miles above the Earth's surface, was equipped with a variety of sample-gathering instruments, including a series of tiny external wires which collect debris as the air rushed past. After each flight, these wires were carefully transferred to a scanning electron microscope and magnified up to 30,000 times to help determine the chemical makeup of the cloud. NASA's volcanic cloud studies looked at the atmospheric debris generated by these natural events, so that today we can better understand their impact on our environment. Launched in 1972, NASA's Pioneer 10 spacecraft accomplished many firsts over the course of its space odyssey. One was a successful passage through the rocky asteroid belt, a feat which greatly alleviated the fears of scientists concerned about damage to far-travelling spacecraft. Having safely journeyed the 2.5 million miles to Jupiter, Pioneer 10 transmitted valuable scientific information back to Earth. Information shedding new light on the composition and evolution of Jupiter and its moons. On June 13, 1983, Pioneer 10 began a journey beyond all the known planets to become the first man-made object to leave the solar system. As NASA's Deep Space Network continued to track the spacecraft out to about 5 billion miles, researchers tried to learn as much as they could about the boundary between the Sun's atmosphere and true interstellar space. Pioneer 10, a spacecraft that has journeyed further than any other to the outer planets and beyond our solar system. A man-made object which has, from a new vantage point, in Whitman's words, looked up from a great silence at the stars. It's called ET, space shorthand for external tank. And by the mid-80s, the 78,000-pound structures, towering like silos over the shuttle's orbiters and solid rocket boosters they support, had successfully carried the 520,000 gallons of liquid hydrogen and oxygen necessary to power the shuttle's three main engines. Although they'd performed flawlessly, providing fuel up to about 80 miles above Earth's surface, then disintegrating into re-entry, their structural design had been under review for some time. By the following summer, a significantly lighter version was completed and rolled out at the Marshall Space Flight Center's assembly facility in New Orleans. By reducing the weight of the tank by some 8,000 pounds, the shuttle would be able to carry an additional 8,000 pounds of cargo into space. One obvious weight reduction measure was taken before the third shuttle flight, when 600 pounds of white latex paint used previously on the tank's outer surface was eliminated, after data from the first two missions indicated that its thermos system would provide adequate protection without the paint. Modifications made at the time include the use of thinner aluminium skin panels. A number of structural stiffeners running the length of the tank had also been eliminated. Once assembled, it was loaded aboard a barge and shipped to the Kennedy Space Center in Florida to be prepared for flight. While the first lightweight tank was used on Shuttle Mission 6, similar ones had already been delivered or were in the process of being assembled for shuttle flights 8 through 19. And while the external tank was the only major element of the shuttle not to be recovered, it was believed that at some future time, a properly designed tank could be used to carry additional cargo into space, or that several redesigned tanks could be linked together to form the nucleus of an Earth-orbiting space station. NASA's revolutionary ET, a lightweight external fuel tank that trimmed away unnecessary pounds and made it possible to increase the cargo carrying capacity of the space shuttle. 1:30 p.m. on April 4, 1982 marked the beginning of Challenger's first flight, when the new orbiter lifted off without a hitch from the Kennedy Space Center, Florida. In its payload bay, the first tracking and data relay satellite, or TDRS. The satellite was deployed from the bay by a spring-powered mechanism. The first spacewalk, or extravehicular activity in connection with a shuttle mission, took place on the 4th and 5th days of the flight, as mission specialists Story Musgrave and Donald Peterson became the first American astronauts in 9 years to walk in space. The EVA consisted of exercises to determine the mobility of their spacesuits, as well as experiments in handling and evaluating workstations and tools to prepare for satellite repair work scheduled for the following year. The astronauts also spent time monitoring the various experiments, including 2 flown on previous shuttle flights. They were the continuous flow electrophoresis system that takes advantage of the weightless environment of space to separate materials with greater purity than is possible on Earth, and the monodispersed latex reactor, which produces microscopic latex spheres for use in medical applications. The crew also gathered information on lightning associated with earthly thunderstorms visible from Challenger's portholes. After 5 days, 80 orbits and 2.2 million miles in space, Challenger completed its maiden voyage with a perfect landing near the Mojave Desert in California. Challenger was then quickly prepared for its next flight, Shuttle Mission 7, to be launched on June 18. The spacecraft looked much like its sister orbiter Columbia. The two were roughly the same size, but Challenger's lighter and stronger construction, together with its more powerful engines, enabled the new orbiter to carry more than 15,000 additional pounds of payload. Mission 7 would for the first time utilize a 5-member team of astronauts, including the first American woman to fly in space, Sally Ride of Encino, California. According to Sally, as soon as NASA made the decision to bring women into the program, they treated them just as they did the men. Her training regime was just as physical, and the flight assignments were just as varied. Commander Bob Crippen of Beaumont, Texas, had already flown the shuttle once before as the pilot of STS-1. That first mission was a test flight to evaluate and verify the shuttle's systems performance. The Space Transportation System was then able to carry a variety of payloads. According to astronaut Bob Crippen, the shuttle's just a big space truck, hired to haul multiple satellites into orbit around the Earth. The only other way of putting up satellites is with expendable booster rockets, which makes the shuttle a more economical and reliable way to get the job done. For example, STS-7 was to deploy 3 communication satellites which were connected to PAMs, or Payload Assist Modules. The PAMs are attached to a rotating table, which in turn is affixed to the cargo bay. The table is spun to give the payload a rotation, and at the right time, springs are used to push the spinning satellite out of the payload bay with about 6,000 pounds of force behind it from the springs. The Payload Assist Modules carry with them a solid rocket motor, which can be used after deployment from the orbiter to boost the satellite into orbit, which is 22,000 miles above the center of the Earth. STS-7 was the first mission to use the Remote Manipulator System, or robot arm, to deploy and retrieve a payload. A West German satellite called SPAS-1 performed a series of experiments in space near the orbiting shuttle before being retrieved. STS-7 was also the first shuttle flight to land at the Kennedy Space Center, Florida. All previous flights had landed in California or at alternate facilities in the western US. That brings us to the end of this edition. We look forward to your company next time. But remember, we are out there. What we can and can't see is out there, and the mysteries between us, although seemingly insurmountable, are encompassed by a disappearing frontier.